In the field of nuclear technology, the United States has always been a global leader. Such as nuclear power plants, nuclear-powered aircraft carriers, nuclear submarines and nuclear weapons, etc., American technology is in the leading position in the world. The United States is the first country in the world to develop an atomic bomb, and it is also the only country in the world that has used an atomic bomb in actual combat. Today, the United States has taken another important step in nuclear fusion technology. According to the public announcement of the Lawrence Livermore National Laboratory of the United States has made a major breakthrough in controllable nuclear fusion technology, realizing the net gain of nuclear fusion energy for the first time. What does that mean? Well, it was in the controlled nuclear fusion experiment that American scientists realized that more energy was produced than injected energy, resulting in a net energy surplus. That is to say, engaging in controllable nuclear fusion is no longer a unilateral continuous energy loss, but can achieve energy surplus. In fact, this is not only the first technological realization of the United States, but also the first technological realization of all mankind. This is an important step for mankind to move towards controllable nuclear fusion and realize the sustainable development of new energy. However, it is just a small step before humans fully master the technology of the entire industrial chain of controllable nuclear fusion. So, how does China, which has been making efforts in sustainable energy, perform in the field of nuclear technology? Okay, let's take a look. Controllable nuclear fusion is directly related to a higher stage of peaceful use of nuclear energy by mankind, and it is also an important technical direction for mankind to solve the problem of energy shortage. At present, all nuclear power plants in the world are built based on controlled nuclear fission technology. In other words, the technology of controllable nuclear fission power plants is quite mature, and there are already 6 countries that have mastered the third-generation controllable nuclear fission power plants, including France, the United States, Russia, China, South Korea, and Japan. In the field of controllable nuclear fusion, human research is still at the laboratory level, the cost is extremely high, and the benefit is zero. The relevant research depends entirely on the financial support of the state, and there is still a long distance from commercial application. And as we mentioned at the beginning of the video, the United States has achieved an income surplus, so what about China? China's top weapons scientist says nuclear fusion power is 6 years away. Peng Shenzhue unveils plans for combined fusion-fission reactor that could make China world's first to achieve the elusive viable energy source. Recently, China has unveiled plans for the world's largest pulsed power plant, which it hopes will help it win the global race for viable nuclear fission-powered energy. The Chinese government has approved construction of the world's largest pulsed power plant with plans to generate nuclear fusion energy by 2028. According to the top nuclear weapons scientist leading the project. Fusion ignition is the jewel in the crown of science and technology in today's world, said Peng Shenzhue, a professor with the Chinese Academy of Engineering Physics. Being the world's first to achieve energy-scale fusion energy release will lay the most important milestone in the road to fusion energy for human beings. Peng, 81, has developed some of China's most advanced small nuclear warheads and served as a top advisor to the country's nuclear weapons program. Under the environmental protection policy of carbon peaking and carbon neutrality, nuclear power generation has become a new power generation model sought after by many major countries due to its superior low emission and cleanliness. The Z-pinch machine, which replicates the fusion reactions of a thermonuclear bomb through magnetic pressure created by an extremely strong electric pulse, is expected to be completed around 2025 in Chengdu, the capital of the southwestern province of Sichuan. The machine will produce 50 million amperes of electricity, about twice as much as the record-holding Z-pulsed power facility, a similar device at the Sandia National Laboratory in the U.S., Peng said. Nuclear powers like the U.S., Russia and China have built a number of Z-pinch machines over the past few decades, some of which have never been officially disclosed, to simulate the extreme conditions needed to develop atomic weapons. These facilities can store a huge amount of electricity and release it in just a few nanoseconds. The electric pulse can create extreme pressure and enough radiation for two lightweight atoms to fuse into a heavier one, and give up some mass in the form of energy. But building a machine that can produce more fusion power output than input is extremely difficult, and so far, no country has been successful. According to Peng's presentation, the Chinese researchers will try to create a nuclear fusion reaction by using the strong electric charge to ignite a small number of the hydrogen isotopes deuterium and tritium. By carefully controlling the process, they hope to be able to cap the pulse energy released to a few 100 million joules, about as powerful as a 20 kilograms, 44 pounds bag of TNT. And in a departure from previous designs, the fusion energy produced by the Chinese facility will not go to the power grid, but drive a swamp of superfast particles to hit uranium, the fuel which will power the facility's fission component. In his conference presentation, Peng said this inclusion of fusion and fission reactors is responsible for the Chinese design's designation as ZFFR. The intention is for the walls of the fusion ignition chamber to be filled with uranium, which will absorb the flying neurons produced by the explosion, causing it to split into two lighter elements, the same process used in existing nuclear power facilities. The uranium fission will increase the facility's total heat output by 10 to 20 times, significantly accelerating the application of fusion energy and making it ready for commercial power production by 2035, according to an estimate by Peng's team. If China's machine is to succeed, it will need many high-performance capacitors to store the electricity and laser-powered switches that can operate instantly without causing a shortage. Other challenges include special wires able to transmit the strongest electric currents on Earth, and a peanut-sized target device to efficiently convert electricity to an ignition charge. Peng said many of these problems had been solved, thanks to new scientific discoveries and technical breakthroughs by Chinese nuclear scientists in recent years. And some of their approaches are fundamentally different from what has been tried in the West. In fact, the Chinese approach significantly simplifies the physical models for computer analysis while relaxing the demand for energy input, he said. This is a big innovation. The researchers said the future power plant could use natural uranium ore, the nuclear waste produced by today's reactors, or thorium, which could meet energy demand for thousands or even tens of thousands of years while producing little radioactive waste. And because the fusion explosion will happen only once every 10 seconds, it will be incapable of generating enough energy to start a chain reaction and cause a meltdown, making the design safe and suitable for most places on Earth, they said. In fact, the Z machine is just one of a range of methods, including powerful lasers and hot plasma caged in a magnetic field, being tried and tested by China and other countries in the race to achieve fusion ignition. Okay, that's all for today. Please put your comments below and share your insightful ideas with other people. Thank you so much for your continuous support. Your precious time with us is highly appreciated. See you.